In this question here, we are supposed to work out the weight of this ruler. And something that we need to remember here is that we are told that there is a mass that was placed at this point, which is of 12 newtons. And at the same time, we are also told further that this ruler is supported by a tension. This tension here, this string, which is having a tension of 17 newtons. And there is a mass which is having a weight of 12 newtons, so meaning it's supported from this hinge that we are having at this given point to where the weight is acting is 0.35 meters. When you are having a question like this, something that you need to remember is that you are going to use the principle of moments. And the principle of moment states that at equilibrium, sum of clockwise moments are equal to the sum of anti-clockwise moments. So in this question, we are going to use that analogy, and we shall say the sum of clockwise moments must be equal to the sum of anti-clockwise moments. So, which means we are going to ask ourselves, which are the forces which are going to give us a clockwise moment, and which are the other forces which are going to give us anti-clockwise moment. So meaning that we are going to assess this weight is going to make this whole system to rotate in this direction, which is a clockwise moment. This weight also of 12 newton is going to give us a clockwise moment, but the tension is going to make the whole system to go in the anti-clockwise direction. So this tension is going to give us anti-clockwise direction. But however, we cannot be able to use it the way it is like this, but we need to resolve this vector into vertical components. So meaning that we are going to resolve this force so that we can be able to get what is the vertical component of the tension force, because this is having a horizontal component at the same time is having a vertical component. But this force that we have here, the tension in the y direction, we can be able to transfer it on this other side. We can be able to transfer it here, and then we can now say, let me just get rid of this. Can be able to say this is now tension in the vertical direction or in the y direction. So meaning that we can be able to use this angle 50 and opposite and hypotenuse in order to get the vertical component. And in that case, Ty, tension in the y direction is going to be 50. Tension in the y direction using trigonometry is going to be 17 sine 50. So that is the tension in the y direction. So the force that is acting upward is actually 17 sine 50. So meaning that we can now say clockwise moment. And looking at this, we can see that if we add 5 plus 0.15 is going to be 0.5 meters. So meaning that the weight is going to act at what distance? The weight usually is acting at the center. So this is going to be 0.25 meters at this given point. That's where the weight is acting. So we're going to go ahead and try to work out clockwise moments, sum of clockwise moment. That would be W times the perpendicular distance from where the force is acting to where the pivot is, which is going to be 0.25 plus 12 newton times the distance from where the weight is acting to where the pivot is, which is 0.35, should be equal to anti-clockwise moment. And the force that is giving us anti-clockwise moment is the tension force, but in the vertical direction. So this is the one that we have gotten to be Ty, which is going to be 17 sine 50 multiplied to the perpendicular distance from this point to where the pivot is, which is going to be 0.5. Now we need to put that into our calculator so that we can be able to work it out. The first one here is going to translate to 0.25 W plus, we need to multiply 12 times 0.35, that translates to 4.2. 4.2 is equals to 17 sine 50. We get the answer times the distance, which is 0.5. That translates to 6.5. 6.5. Then we can now say therefore this 0.25 W equals to 6.5 minus 4.2, right? Subtracting this, we're getting 2.3. So we can say now W equals to 2.3 divided by 0.25. And if we work out this, we are going to get 0.25 is going to be 9.2 newtons, because we are talking of the weight. The weight of this ruler is actually 9.2, the one that we have gotten at this given point.